ever wondered how objects in programming languages are created? Let's dive into the fascinating world of object-oriented programming, where the birth of an object is an event of paramount importance. Picture a class as a blueprint, a set of instructions that guide the creation of an object. But who ensures that these instructions are followed, that every attribute is correctly initialized, and that the object is set up perfectly? Enter the constructors, the unsung heroes of object creation. A constructor is a special method in a class that springs into action the moment an object of the class is created. Its primary role: to initialize the object's attributes and perform any setup necessary for the object to function properly. Imagine a constructor as a meticulous engineer, ensuring that every component of an object is in the right place and performing the right task. So how does a constructor work? It's quite simple, actually. Constructors are automatically called when an object is instantiated. They can even take parameters to customize the initialization process. Think of it as a personalized setup for your object, where you can specify how you want your object to be initialized. But what if an object doesn't need any special initialization? Well, that's not a problem at all. In such cases, a default constructor is used. It's like a safety net, ensuring that an object is still properly created even when no specific instructions are provided. Constructors, with their precision and adaptability, are fundamental to object-oriented programming. They ensure that an object starts its life cycle in the best possible state, ready to perform its functions and interact with other objects in the program. So, constructors are like the midwives in the delivery room of programming, ensuring every newborn object is ready to take on the world. Now that we know what constructors do, let's dive a little deeper. Imagine you're a chef preparing a dish. You need to gather all the right ingredients, prepare them in a certain way, and combine them to create the final product. In the world of object-oriented programming, a constructor is like that chef. It prepares an object for use by initializing its state, allocating resources if necessary, and setting default values for its attributes. Constructors are special methods within a class, and they spring into action the moment an object is created. This process is automatic, meaning you don't need to call a constructor explicitly. It's like having an assistant chef who starts preparing the dish as soon as you decide what to cook. But what if you want to customize your dish? What if you want to add a little extra spice or use a different type of oil? Just like a chef can alter a recipe based on taste preferences, constructors can also take parameters to customize the initialization process. For instance, if you're creating an object that represents a bank account, you might want to start with a certain balance, set a specific account number, or assign a unique user ID. By passing these values as parameters to the constructor, you can ensure that each object is prepared just right, with the attributes that make it unique. But remember, while constructors are there to help set up objects, they're not meant to do all the work. Constructors should focus on initializing an object's state, not performing complex calculations or operations. Just as a chef wouldn't try to serve the customers or wash the dishes while preparing a meal, constructors should stick to their primary role, getting objects ready for use. So next time you create an object, think of its constructor as its personal chef, diligently preparing it for its role in your program. From setting default values to accepting customized parameters, constructors play an essential part in object-oriented programming. Just like a chef prepares a dish by adding the right ingredients, a constructor prepares an object with the right attributes. But what happens when an object has served its purpose and is no longer needed? Well, that's where the unsung heroes of object-oriented programming, the destructors, come into play. Imagine a destructor as an object's personal undertaker. Its main job: to manage the object's final rights, ensuring everything is tidied up before the object is removed from memory. This is a crucial step, as it helps to prevent memory leaks and keeps your program running smoothly. Destructors are responsible for performing cleanup tasks, like closing file handles or database connections, and releasing any resources that the object was using. They're the ones who turn off the lights, lock the doors, and sweep the floors after an object has completed its mission. Now, you might be thinking, great, another thing I have to remember to code. But here's the good news. In many languages, you won't need to explicitly define a destructor. If you're working in a language with a garbage collector like Python or Java, the garbage collector will automatically clean up unused objects for you. It's like having a built-in janitor for your code. However, if you're coding in a language where manual memory management is common, such as C++, You'll find destructors are a bit more hands-on. In these situations, destructors can be a powerful tool for effective resource management. So how do you recognize a destructor when you see one? While their names can vary across languages, they often have a recognizable format. For example, in Python, a destructor is typically named, but remember, whether they're implicitly called when an object goes out of scope or explicitly called in your code, destructors should always be designed to handle exceptions appropriately. This ensures that even if something goes awry, your resources are still properly managed and your program can continue to run smoothly. So, destructors are like the janitors of programming, cleaning up after an object has done its job. They might not get all the glory, but without them, our programs would be a lot messier. Now that we've covered the life cycle of an object, let's look at destructors in more detail. Destructors are like the final curtain call for an object. They're the cleanup crew, stepping into action just as an object is about to exit the stage. Their primary role is to release resources that the object has been using. These resources could be anything from file handles and database connections to memory. Imagine you're running a computer program that involves opening a file to read some data. Once the program is done with the file, it needs to be closed to free up system resources. This is where a destructor comes in. The destructor makes sure the file is closed properly, ensuring that no resources are left hanging. But destructors don't just deal with file handles. They could also be handling database connections. If your program is interacting with a database, it's crucial to close the connection once you're done. Leaving a database connection open could lead to performance issues and even security risks. A destructor takes care of this, closing the connection and keeping your program safe and efficient. Memory is another critical resource that destructors help manage. In languages like C++, where manual memory management is common, a destructor frees up any memory that the object was using. This helps prevent memory leaks, which can slow down your program and eventually cause it to crash. The way destructors are called can vary. In some cases, they're implicitly called when an object goes out of scope. That means when an object is no longer needed, the destructor automatically steps in to clean up. In other languages, you might need to call the destructor explicitly. This gives you more control, but also requires you to be vigilant about calling the destructor at the right time. Just like a recycling plant ensures nothing goes to waste, a destructor ensures no resources are left hanging when an object is done. So next time you're working with objects, remember the vital role of destructors. They're the unsung heroes of object-oriented programming, working behind the scenes to keep your programs efficient and reliable. Before we wrap up, there are a few important things to keep in mind about constructors and destructors. First up, we have implicit and explicit calls. When you create an object, the constructor is automatically called to initialize the object's state. That's an implicit call. Destructors, on the other hand, might be called implicitly when an object goes out of scope, or explicitly depending on the language you're using. Next, let's talk about memory management. If you're coding in a language with automatic memory management like Python, which has a handy garbage collector, you might not need to explicitly call destructors for memory cleanup. But if you're working in a language where manual memory management is the name of the game, like C++, destructors become your best friend for releasing resources. Moving on to naming conventions. The names of constructors are standardized across the board, like in Python, and they're automatically called during object creation. Destructors, however, vary from language to language. For example, in Python you'd use, and depending on the language, they may be invoked automatically or require an explicit call. Last but not least, we have exception handling. It's crucial that both constructors and destructors are equipped to handle exceptions appropriately. This ensures that resources are properly managed even if errors occur. Remember, unhandled exceptions can lead to memory leaks or other issues, so keep things tidy. These considerations might seem like minor details, but they have a major impact on the stability and reliability of an object-oriented program. A well-planned constructor and destructor can be the difference between a program that runs smoothly and one that crashes and burns. So the next time you create or destroy an object in your code, remember, it's all about the constructors and destructors.